Hello everyone. A very good afternoon all of you guys over here. So, welcome to this particular session. I welcome you all to this particular session of solid state. The very first session of solid state wherein we are actually talking about JEE series, that means the Target JEE 2023 series. Till now we have finished only one chapter, that is solution. Okay, we were actually focusing on class 12th term 1 syllabus and we actually finished solutions. In this particular session, I am going to start the solid state. So, my dear ones, I welcome you all with all my heart in this particular session, and I believe that you are going to learn very much, I think, a keen knowledge of solid state herein with me. So, it's me Rakhi, your mentor for this particular session, and I welcome you all for the session solid state for Target JEE 2023 series. So, hi Akash, hello Raja, good afternoon dear ones. So dear one, if I'm actually visible and audible to you, just let me know by saying hello ma'am, hi ma'am, giving me the green signal so that I can proceed further for the session. Hope this particular solid state is actually gonna be one of the good session for you guys, wherein you understand each and everything told by me over here. So yeah, hello Shubhra Jyoti, hello Rishabh, good afternoon dear ones, welcome to the class. Hi Ashwant, good afternoon. Hi Akash, good afternoon. So dear ones, come on, be fast and let your friends know that the session has started so that they can also have a boost in their preparation. Okay. Okay, Rishabh. So it will take around 7 to 8 sessions and then we'll be having the Menti quiz for this session. Afterwards, the important JEE questions. Hello, Raja. Hello, Mr. Noob. Good afternoon, dear ones. Okay. So herein, let me just go ahead with this particular session. So Akash, it's my advice to you that please watch these solutions. Okay, it was the very first chapter we discussed for class 12th term 1 examination, and over here I have come along with solid state, wherein in today's session I am going to talk about solids and unit cells. Okay, a new topic for you guys. Well, I know you actually have heard about solids in your 9th class, in your 10th class, also in your 11th class, but in today's session we'll be talking something new about solids, and of course we'll be actually moving ahead with the topic unit cells. Well, if I just talk from JEE point of view, this particular chapter is really very important. 1 and 2 questions do come from this particular chapter, so you need to go thorough with this particular chapter, and I'll just request you don't miss any of the sessions. Okay, so yeah, Shubhra Jyoti, let's start our session. Very soon, Akash, we'll be talking about organic chemistry also, but let's actually quickly deal with the physical chemistry. Let's finish the physical chemistry portion. Okay, and then we'll be talking about the same. Fine. So before I move ahead and talk about something, not something, the whole session dedicates to solids, I just want to tell you that please do subscribe the channel for the further notifications of the classes, which is actually going to come further in the future. Okay, and also do share this particular session among your friends, your peer groups, so that they can actually know that the solid state has been started over here on Akash Byju's JEE platform, so that they cannot miss a single session. Well, dear ones, do like the hit button, I mean to say do hit the like button, and let's move ahead. Okay, solids. So what you actually feel about solid, what you actually know about solids. I think you do have a prerequisite knowledge for the solids. You have studied in your 9th class, okay. Here, you might have studied in most of the chapters, okay, of the physical chemistry. In 11th, you studied about the gaseous state. Okay, and now we are going to talk about the solid state. Initially, you might be having some particular knowledge for solids. As Shubhra Jyoti said, it's actually having the definite shape and volume. Rishabh says it's tightly packed. Yes, of course. So Yeah, of course, Akash. Absolutely right. So, this is the basic thing we actually talk about solids. Closely packed structure. Absolutely right, Sandeepan. Absolutely right. Yeah. Yeah, Mayur. They have definite shape and volume. Okay, totally okay with you guys. Well, let me tell you one thing, that if I just talk about solids, yes, you all are actually giving me the right answer. Solid state has a strong interparticle attraction and negligible thermal motions of particles. Okay, so as you all said, it's absolutely right. But if I just talk in terms of what? Attraction. Okay, so solids do have strong interparticle attraction and the negligible thermal motions of the particle. We'll not say that the solid particles do have what? The translational motion or or you can say the rotational motion. Fine, they can have vibrational motion, but if I talk about the translational and rotational motion, they do not have basically. So they do have the negligible thermal motion of the particles. Absolutely right, Akash, you are absolutely right. This was the very first thing, because they are actually tightly packed. Okay, they are actually tightly packed. Fine, yes, they have high intermolecular forces of attraction. This is the very basic thing you all know. Okay, moving ahead, and if I just talk about the properties of the solids, if I just talk in terms of the properties of the solids, as you all said, that it do have a definite mass, volume and shape. Okay, see, if I just talk about this particular fabric is this solid, liquid or gas? Obviously, you will say, ma'am, this is solid, but it do have definite volume. I'll say the volume is same, fine, the mass will be also definite, but can you just see the shape? Do it have a definite shape? No, it's not having a definite shape, ma'am. So yes, saying that it do have a definite shape, it can account for some of the cases, it cannot account for some of the cases. As in the case of the fabric, since it's a solid, I'm talking about volume, sahi hai. Volume will be fine, okay, volume is fine. And if I just talk about the mass, it's also fine. But if I just talk about the shape, then, so here it is actually saying that in some of the cases we do account for that it do have the definite shape. In some of the cases we say that it do not have a definite shape. Isn't it, Akash? Am I right, my dear ones? Rishabh, Shubha Jyoti, Mayur, Sandeepan. Are you agreeing with me all? Fine. Moving ahead, and yes, it do have least interparticle distance in solids. We do have least interparticle distance in solids as compared to liquids and gas. Okay. So in solids, we know that the particles are intact with each other. Fine. They do have least interparticle distance. Okay. In water, if I just talk about, yeah, the particles are somewhat far away from each other. But in the gaseous state, if I just talk about the particles, obviously they are randomly moving. They are randomly moving, isn't it? Yes. So, strong interparticle forces of attraction is what we see in solid. It's one of the properties we are going to discuss for the solids. Moving ahead, we can say that the particles cannot flow. Of course, we know that when we are talking about solids, herein the particles will not flow. Talking about the constituent particles, okay, so constituent particles, they do have the fixed positions. They can oscillate about their mean positions. That means they can have vibrational motions. Okay, they can have vibrational motion. As I told you, they cannot have rotational and translational motion, but yes, they can actually vibrate about their mean position. Like this, if this is a solid, so yeah, they can actually vibrate. Isn't it? Yes. So Roshan, what's the thing you are not actually understanding? Let me know. What you have not understood, let me know. The main point. Okay. Well, it's very simple. Solids are rigid and incompressible. Mostly we say it. Okay. This is what we have, this is what is written in your NCERT textbooks, that solids are basically rigid and they are incompressible. Okay. Fine. So Roshan, just let me know what you haven't understood about the things I have just said for the solids. Okay. Now moving ahead, and if I just talk about the classifications of the solids. Okay. Now the classification of the solids, if I talk about, it's generally divided into two categories. The very first, if I just talk about, based on the forces, based on what? Based on the forces among the constituent particles. If I just talk about the classifications of the solid, I'll say the very first classification, that is based on what? It is based on the forces. It is based on the forces, based on the forces among constituent particles. Based on the forces among constituent, okay, yeah, constituting particles. Isn't it? Yes. Okay, and if I just talk about the second classification, it is based on the arrangement of the particles. It is based on arrangement of particles. Arrangement of particles. Okay. So we do classify solids into these two particular categories. Yeah. Okay. Solids can have translational and rotational motions, but solid particles doesn't. Absolutely right, Akash. Yes, that is what I've said. See, if I just talk about solid particles, this is, suppose this is the solid, okay, and if I just talk about the solid particles, they do not have rotational and translational motion, okay, but they will be having vibrational motion, okay. They are going to oscillate about their mean positions, having vibrational motions. Fine, okay, okay, cool. It's Priya Ranjan who says, based on the force of thermal and international classified crystalline or acrystalline. Okay, we'll be reaching to that particular part also. Just let me handle the session and I'll let you know very soon. Hello, Mr. Sudhanshu. Good afternoon. Welcome to this session. So when I just talk about the classification of the solids based on the forces among the constituent particles, the particles over here I'm going to talk about atoms, molecules and the ions. Okay. So over here we will be talking about which particular attractive force is there between the constituent particles. When I just talk about based on the forces among constituent particles. Okay. Well, for this particular session, I am going to take into account based on arrangement of particles, classifications of the solid based on arrangement of the particles. I mean to say, किस तरह की geometry में वो arranged हैं. The particles are arranged, okay, in which particular type of the geometry. We are going to talk about this. Okay, when I am talking about the arrangement of the particles, okay, किस sequence में, किस frequency में वो repeat हो रहे हैं, okay, that is what I am going to talk about when I am talking about based on arrangement of particles. I think the things are getting into your mind. Fine. Well, when we talk about based on the forces among constituent particles, we deal with the molecular solids, we deal with the covalent solid, we deal with the ionic solids, okay, we deal with the metallic solids. Okay, for this particular session, I'm not taking into account all of these things. I will be actually discussing the crystalline and amorphous solids. Okay, so when I just talk about the classifications of the solids based on the arrangement of the particles, based on what? The arrangement of the particles, I mean to say किस तरह की geometry में वो arranged है, okay, किस sequence में, किस frequency पे वो particular particles repeat हो रहे हैं. On that particular note, we'll be discussing about the crystalline solids as well as the amorphous solids. Okay, we'll be talking about crystalline solids and amorphous solids. That is what we'll be talking about. Well, when I just talk about the crystalline solid, okay, and talk about the amorphous solid. So whenever the terms amorphous comes into the mind, it is basically the, what should we say, that यहाँ पर talking about amorphous solids, I'll say uniformly solids नहीं है. These are not uniform solids, okay. Not uniform. When we talk about amorphous solids, they are not uniform. Okay, they are not uniform. Okay, fine. Is that thing clear? Fine. Not uniform. Oh yes, uniform solids nahi hai. When I just talk about the crystalline solids, perfectly arranged solids hote hain ye. I mean to say particles, they follow a definite regular arrangement. डेफिनेट रेगुलर अरेंजमेंट को फॉलो करते हैं. व्हेन वी टॉक अबाउट क्रिस्टलाइन सॉलिड्स, अरेंज्ड होते हैं. टॉकिंग अबाउट अमॉर्फस सॉलिड्स, यहाँ पर देयर इज नो पर्टिकुलर पैटर्न. ओके, द पार्टिकल्स आर रैंडमली अरेंज्ड. पार्टिकल्स रैंडमली अरेंज्ड होते हैं. In case, if I just talk about one particular thing, suppose if I melt the sulfur, okay, we have melted the sulfur, okay. Now, when I just talk about the amorphous solid, अभी ये जो example मैंने sulfur का लिया है, ये मुझे बाद में लेना चाहिए था, but no issues. मैं आपको कुछ explain करना चाहती हूँ. In case when I just talk about the melting point and enthalpy of fusion, kind of like these things, if I just talk about, तो सपोज मैंने सल्फर को मेल्ट किया. ओके, आई मेल्टेड द सल्फर. ओके, व्हेन आई जस्ट टॉक अबाउट द अमॉर्फस सॉलिड्स, ठीक है, तो यहाँ पर मेल्टेड सल्फर को मैंने रैपिडली कूल कर दिया, एकदम से कूल कर दिया, एंड मुझे कुछ रैंडम सा पर्टिकुलर स्ट्रक्चर मिला जिसको मैंने नाम दिया प्लास्टिक सल्फर. वेयर एज अगर मैं क्रिस्टलाइन सॉलिड्स की यहाँ बात करती हूँ, तो यहाँ पर मेल्टेड सल्फर को जब हम धीरे 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 कूल अप करेंगे तो हमें हमारा क्रिस्टलाइन पर्टिकुलरली रोम्बिक सल्फर मिलेगा. ठीक है, तो ये बात मुझे अभी थोड़ी देर बात करनी थी, बट स्टिल आई टॉक्ड अबाउट है इन ऑर्डर टू मेक यू अंडरस्टैंड कि क्रिस्टलाइन सॉलिड्स में वी डू हैव द डेफिनेट रेगुलर अरेंजमेंट, वेयर एज इन केस ऑफ अमॉर्फस सॉलिड्स पार्टिकल्स जो होते हैं वो रैंडमली अरेंज्ड होते हैं. हेयर इन यू कैन सी वन पर्टिकुलर थिंग लाइक दिस. तो आप यहाँ देख सकते हैं, अगर मैं क्रिस्टलाइन सॉलिड्स की बात कर रही हूँ, इफ आई एम टॉकिंग अबाउट क्रिस्टलाइन सॉलिड्स, आई विल से यस दे आर लॉन्ग रेंज order. They are long range order solids, okay, isn't it? Yes, because over here there is the perfect definite arrangement of the particles, so we can have the long range particles over here. I mean to say long range order we can have of the crystal. You can just have a look. Whereas if I just talk about the amorphous solid, so over here in the picture only you can just see कि कहीं पर तो we are seeing the long range order, कहीं पर we are seeing the short range order. Can you just see they are randomly arranged? They are randomly arranged basically. Isn't it? Is the thing clear to you? ओके, रैंडमली अरेंज्ड है, तो कहीं तो हमें लॉन्ग रेंज दिख रहे हैं, कहीं शॉर्ट रेंज दिख रहे हैं, तो कुछ पता नहीं चल रहा है. दे आर रैंडमली अरेंज्ड. यस, करण सैनी, लेट मी टेल यू वन थिंग, जरूरी नहीं है कि अमॉर्फस सॉलिड्स को हम स्पेसिफिकली ये मेंशन कहें, स्पेसिफिकली हम मेंशन करें दैट दे आर शॉर्ट रेंज ऑर्डर. जरूरी नहीं है, वहां कोई ऑर्डर भी नहीं हो सकता है. ओके, वहां कोई ऑर्डर नहीं हो सकता. आई नो इन एनसीईआरटी टेक्स्ट बुक ये बिल्कुल साफ लिखा हुआ है कि अमॉर्फस सॉलिड्स दे आर शॉर्ट रेंज ऑर्डर, एज वेल एज इफ आई टॉक अबाउट क्रिस्टलाइन सॉलिड्स दे आर लॉन्ग रेंज ऑर्डर. फॉर क्रिस्टलाइन सॉलिड्स वी कैन डेफिनेटली से दैट दे आर लॉन्ग रेंज ऑर्डर बिकॉज द पार्टिकल्स आर अरेंज्ड वेरी मच प्रॉपरली. Whereas in case of amorphous solid we can say them that yeah they are short range order, but जरूरी नहीं है. ओके, हम नो ऑर्डर भी कह सकते, कोई ऑर्डर भी नहीं हो सकता. इज इट? यस मैम. So over here, yes, I have written over here the same thing as written in your NCERT textbook, but obviously when I'm making you explain something, I need to make you rectified there. So over here, crystalline solids, they are long range order in the arrangement, and yeah, they are short range order in the arrangement. Hope most of you have understood that what are long range orders and what are short range orders. Long range orders की अगर हम बात करते हैं, that means long range, I mean to say दूर तक connectivity बहुत अच्छी है. Okay, and if we are talking about short range, कहीं connectivity अच्छी है, कहीं connectivity नहीं अच्छी है, like kind of like this thing. I want to make you clear about the same. Okay, moving ahead, and this is what I want to talk about, short range order and the long range order. Fine, Rishabh, just wait, I'll be explaining you about the same thing. You need to have patience. Okay, so moving ahead, if I just talk about crystalline solid, they are produced by slow cooling. I told you already, they are produced by slow cooling under controlled conditions of liquid. The crystalline structure is also dependent on the conditions, whereas if I talk about amorphous solids, they are produced by rapid cooling of the liquid. I just took the example of melted sulfur. Okay, melted sulfur. Okay, fine. I took the example of melted sulfur. Yes. So if I just cool that melted sulfur rapidly, एकदम से मैंने उसको कूल कर दिया. Okay, so what I'm going to get, I'm not going to get a perfectly crystalline solid, I'm going to get a plastic sulfur kind of a thing. ठीक है, एकदम से कूल कर दिया. Yes, Priya Ranjan, wait a minute, have patience. यार, I cannot explain you the whole chapter within 5 minutes. Is it possible? So you need to wait. You need to wait, guys. Okay. Santosh will come to that particular part also about unit cell. So wait and hold your thoughts. Okay. Have patience. We'll explain you each and everything crystal clear. Believe me. Okay. So यहाँ पर I took the example of what? I took the example of melted sulfur. Melted sulfur को एकदम से rapidly cool किया तो हमें कुछ random सा plastic sulfur मिला. लेकिन if we cool down the melted sulfur slowly, slowly and slowly, we are going to get a very beautiful rhombic sulfur. Okay, we are going to get the same. Isn't it? Yes, ma'am, of course. So, if I just talk about the crystalline solid, it do have a fixed or sharp melting point and enthalpy of fusion. Whereas, if I talk about amorphous solid, it do have a range of temperatures in which they melt as melting point and the enthalpy of fusion is not fixed. Okay, when I just talk about enthalpy of fusion, what do you mean by enthalpy of fusion? So, enthalpy change that occurs when 1 mole of a solid, enthalpy change that occurs when 1 mole of a solid is converted into liquid without the change in temperature at constant pressure. Is it clear to you? Yes. So, if I'm saying that amorphous solids, they do not have sharp melting point and enthalpy of fusion, क्या मतलब है इसका? See, अलग-अलग तरह के structures we actually get in amorphous solids because the particles are randomly arranged. किसी में bonds ज़्यादा आपको दिखेंगे, किसी particular structure में bond कम दिखेंगे, तो यहाँ पर range of melting point आपको मिलेगा. Okay, so they do not have the sharp melting point as well as the enthalpy of fusion. Whereas if I talk about crystalline solids, yes, they do have the sharp melting point and enthalpy of fusion. Well, abhi somebody asked me about the graph, cooling graph. Priya Ranjan ne mujhse पूछा था. Yeah, of course. So here are the cooling graphs which I need to make you understand over here. है ना? Yes. Okay, guys. Fine. Hello, Mridul. Yes. So if I just talk about the cooling curves over here. Talking about the crystalline solid के बारे में पहले बात करते हैं जहां पर I told you धीरे 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 cooling होती है and then we actually get a perfectly crystalline solid, isn't it? Yes, of course, ma'am. Okay, so यहाँ देखिए it's the temperature versus time graph. Okay, so it's the liquid and we are actually, what we are doing, we are actually freezing it. We are actually freezing it down. Okay, fine. So, as the temperature decreases, we actually know, that the liquid will be actually going to freeze. Okay. So, at this particular point, what you are going to see? A very small crystal of the ice you are going to just see. A very small crystal of the ice. At this particular point, very small crystal of the ice, very small crystal, okay, of ice. That means liquid has started to freeze at this particular point, Is the thing clear? And now there is the transition that is going to take place from liquid to solid. That means the liquid state has started converting into the solid state. This whole thing I'm going to talk about, over here. Fine. At this particular point, the total liquid, okay, whole liquid has been converted into solid. At this particular point, whole liquid has been converted into solid. पूरा का पूरा liquid जो था, it has converted into solid. That is what I want to say. Clear? Okay. So what is actually happening over here? What I want to say that this is basically the freezing point. This particular point is the freezing point. Okay. So वक्त I mean to say with the time, what is actually happening? With the time, temperature is actually decreasing. With the time, temperature is actually decreasing. Okay. Now, freezing of liquid to produce crystalline solid is basically an isothermal process. Freezing of what? Liquid to produce crystalline solid is a isothermal process. Is the thing clear to you? Akash, Mridul, Santosh, Priya, now it's been clear to you. This is the cooling curve of the crystalline solid I have talked about, where this particular point, at this particular point, very small crystal of the ice we actually saw. Fine? Yes, yes, of course, fine. And over here, this is the transition from liquid to solid. लिक्विड सॉलिड में कन्वर्ट हो रहा है, लगातार हो रहा है. यस, ओके मैम. एंड यहाँ देखिए, at this particular point the total liquid has been converted into solid. Okay ma'am, okay, and this is the solid we are going to actually get then. Fine, clear? Okay, so liquid ko what we are doing, we are actually freezing the liquid. We are actually freezing the liquid. With the time, temperature is actually decreasing, and freezing of liquid to actually produce crystalline solid is actually the isothermal process. Please write it down, this particular point. Freezing of liquid to corresponding crystalline solid is isothermal process. You need not to forget this. You need not to forget this. Is it clear? Fine. So over here, what we are actually seeing, what we are actually talking about, enthalpy of fusion we are actually talking about. Okay? Okay, over here the concept of latent heat of fusion you can just talk about, it also come. Fine, latent heat means the hidden heat. Okay, so that particular heat is actually required to convert the liquid into solid, keeping the temperature constant. So over here you can see the temperature remains the constant. Temperature remains the constant. But as time passes, what is actually happening? As the time passes, temperature is actually decreasing. वक्त बीतने के साथ temperature कम होगा. Here comes the concept of latent heat of fusion. Is the thing clear? Yes. Okay, fine, cool. So crystalline solid का ये curve आपको समझ में आ गया? If that's the case, please give me the thumbs up. Okay. Just say yes, ma'am. We have understood. If you have any doubt, let me know here only. Let me know here only, dear ones. Okay. Fine. Cool. Just let me know yes or no so that I can move and make you explain about the amorphous solid, the cooling curve of amorphous solid. Okay, Priyaranjan. Fine. If I just talk about the amorphous solids, which I say they are not uniform solid, So again, dear ones, this is the very first point wherein what we are seeing, we are actually going to see the crystal, okay? The very first crystal appears over here. The very first crystal appears over here. First crystal appears here. But as we know that amorphous solids are not uniform solids, okay? कहीं पर bonds ज़्यादा हैं, कहीं पर bonds कम हैं. So we do see the range of melting point. Okay, we actually do see the range of temperature freezing the liquid. Okay, we are going to see a range of temperature. We are going to see, this is what the range of temperature. This is the range of temperature that is freezing the liquid. That is actually freezing the liquid. Okay. यहाँ पर what is happening? यहाँ पर I just want to say that yes, the temperature is continuously decreasing. The temperature is continuously decreasing. Fine. And a point is going to come where the total liquid, the full liquid is going to actually converted into the solid state. Yes, not fixed heat of fusion, as well as they do not have the sharp what? Melting point, you can say. But since over here we are talking about the cooling curves, we can say the freezing point. They actually have the range of temperature. They do have the range of temperature, freezing the liquid basically. Freezing the liquid basically. And a point is going to come where the whole of the liquid is going to get converted into the solid state. So they do not have the sharp freezing point, you can say, as well as they do not have the sharp heat of fusion, you can say. The amorphous solid. Akash, Priya, is the thing clear to you? Just let me know, because देखिए ये कर्व आपको समझना बहुत ज़्यादा ज़रूरी है. Okay, so if I just talk about, this is the solid. If I just move from here, this is the solid. At this particular point, we are going to see what? If I just take the graph from the back side also, if I just talk about the graph from the back side, that means from converting of solid to liquid, you can see that they do have what? The range of melting points. Okay, solid को liquid में convert करने के लिए, yes, they do have the range of melting point. You can just have a look. Yes or no? Clear? Each and everything is clear over here about the graphs regarding crystalline solid and the amorphous solid. Is the thing clear? Fine. So hope that's all. So over here, when we are moving like this, that means we are giving the temperature to the solid. Okay, we are providing the heat to the solid. A point comes when a solid just is converted into liquid. Okay, fine. So you can just say that the melting point of a solid, we have reached at this particular point where the solid melts. Okay, I'm talking about the amorphous solid, and this is the range of melting point wherein the solid is actually converting into liquid. At this particular point, what is actually happening? At this particular point, what we are seeing, that yes, most of the solid has been converted into the liquid, and so far again we can see it's the total liquid we are going to get. Okay, Smriti, what you want to ask? Repeat what you want to say. Okay, let's not actually create a confusion for you all, guys. Oh, these actually are the cooling curves of the crystalline solid and amorphous solid. Fine, crystalline solid and the amorphous solid, wherein what we are actually dealing with, we have just said they do not have the sharp melting point. For the amorphous solid, they says that they do not have sharp melting point as well as the heat of, or you can say enthalpy of fusion. That's absolutely right. So if I just talk about that particular thing, that particular scenario, that they do not have a sharp melting point. Yes, they do not have a sharp melting point. They do have the ranges of melting point. Okay, they do have the range of melting point. Since amorphous solids are not uniform solids, they are not uniform solids, okay, is the thing clear? So over here, when we give the temperature to the solid state, okay, like this, we reach this particular point, the melting point of the solid, I can say. And yes, since it's not uniform solid, so we do actually see the range of melting point. At this particular point, what we are seeing, that whole of the solid has been converted into liquid. Fine. So this was about the melting point I talked about. If I just talk about the freezing point, you can just do the vice versa of it. The things have been clear? Okay. So guys, Nikhil, Rishabh, Akash, Priya, Smriti, and everyone else, whoever is listening to me for the cooling curves of crystalline solids and amorphous solids, the things have been clear to you? Each and everything is in your mind or not? Just let me know, guys, because it's very, very important and I need to have clarity. Okay, and I just need to have clarity. Fine. Okay. Priya, if you are saying amorphous solid does not depends upon the time, see, over here we have taken the temperature versus time graph only. So हम कह सकते हैं with the time, जैसे हमने crystalline solid के लिए कहा, टाइम बीतने के साथ में टेम्परेचर कम हो रहा है, ऐसे यहाँ पर भी जैसे जैसे टाइम बीत रहा है, ओके, जैसे जैसे द टाइम इज एक्चुअली गोइंग अहेड, obviously the temperature is decreasing, dear one. Okay, fine. So dear ones, I just request you, thank you so much, and we'll move ahead and let's talk about one more particular thing about anisotropic and isotropic. Okay, fine. Prerna, I'll request you just rewind the particular session and just please listen to what I have said. Okay, Just rewind the session and listen to what I've said for the crystalline solid and amorphous solid and their corresponding cooling curves. Please now don't spam. Okay. Talking about anisotropic and isotropic property. Okay. Anisotropic property means different values of the physical properties in different direction. Okay. Different values of physical properties in different direction we are actually talking about. Okay, no issues. So, okay, if I just take the example of graphite, okay, the crystalline solid. I'm taking the example of crystalline, I'm taking the example of graphite when I'm talking about in regard of crystalline solid, okay. So just have a look over here. Fine, any issues? No issues, fine. And obviously, what I'm going to have this and this over here. Okay, cool, ma'am. This, okay. Fine. Moving ahead, this, and this. Cool. Any issues? No issues. There shouldn't be. Okay. Now wait a minute. If I cut this graphite like this, if I just cut the graphite like this, okay, parallel to the plane. If I cut the graphite parallel to the plane, okay. So over here, these are basically weak van der Waals forces, okay. This is actually weak van der Waals forces we are talking about. If I am cutting the graphite parallel to the plane, whereas in case if I just cut the graphite perpendicular to the plane, if I just cut the graphite perpendicular to the plane. Okay, so over here if I cut from here, what I'm actually cutting? It's the strong covalent bonds and I require more energy. Strong covalent bonds, I'm actually cutting it down. Okay, so cutting the weak van der Waals forces is actually requiring the less energy, but cutting the strong covalent bonds requires the more energy. What I mean to say over here, I am measuring the mechanical strength over here. I'm talking about the mechanical strength since I'm talking about anisotropic property for crystalline solid. So when I just cut the graphite parallel to the plane, I require less energy, and when I cut the graphite perpendicular to the plane, I require more energy. Okay. So over here, what I want to say, it's हमें एक ऐसी पर्टिकुलर प्रॉपर्टी मिल गई जो अलग अलग डायरेक्शन में अलग अलग वैल्यू रखती है. Okay, when I talk about parallel to the plane, it's the less energy. When I talk about the perpendicular to the plane, it requires more energy. So we have got a property which do have different value in different direction. Different value in different direction. Okay, so एक भी particular property अगर डायरेक्शन डिपेंडेंट होती है, it's anisotropic since we are talking about crystalline solid. I think you have got the point. Different values of physical properties in different direction I have given and explained you through graphite example. Hope that is clear. Talking about amorphous solid. अच्छा, amorphous solid के बारे में बात करते हैं. They do have same values of the physical properties in all direction due to random arrangement of the particles. देखिए, ये कहना कि इनकी जो प्रॉपर्टीज होती हैं, फिजिकल प्रॉपर्टीज, दे आर सेम in all the different directions due to random arrangement of the particles. Rather we can say one thing, since यहाँ amorphous solid में what we find is it's basically the chaos that is happening in amorphous solid. Amorphous solid में what we basically say it's not uniform solid, chaos हो रखा है यहाँ पर. Yes. So यहाँ पर we are going to measure average. Okay, so if we actually measure the average properties, okay, if we actually talk about the average of all the properties, yes, they are going to come same in each and every direction. I mean to say, अगर हम average नापेंगे किसी भी particular direction में, तो वो same आएगा. Since it's not uniform solid, okay, so when we are actually measuring the average of all the properties we are taking into account for, they are going to come same in all the direction. Fine, ठीक है. तो यहाँ पर ये कहना कि amorphous solid isotropic है, it's actually right. But over here we are going to measure the average of the properties that we are applying. ठीक है. So अगर हम एवरेज मेजर कर रहे हैं किसी भी पर्टिकुलर प्रॉपर्टी का, वो हर डायरेक्शन में सेम आएगा. दैट इज आइसोट्रोपिक. एनाइसोट्रोपिक का आई हैव टोल्ड यू ऑलरेडी. Hope that is clear. Fine, Priya, it's clear. Ravi, Akash, Mr. Smart Insan, clear हो गई ये वाली चीज आपको. See, I'm actually putting the efforts to make you each and everything clear over here. Fine. So यहाँ देखिए, it's the crystalline solid. Yes, crystalline solid में हमने यहाँ पर what we actually talk about the anisotropic thing. So they are saying that they do have different values in different directions. So this is what. Here you can see a straight line, here you can see a diagonal line. That is what I want to clear out. Okay, talking about amorphous solid, they have actually shown us that if we move in any of the direction, we are going to get the same particular property. Okay, so again, for the amorphous solid, they do have the same value of the physical properties in all different direction due to random arrangement. Okay, so they do have what? Same value of the physical properties in different directions due to random arrangement of the particles. एक तरह से average, जो हम average measure करने वाले हैं वो same आएगा. Okay, for the amorphous solid. Yes. So over here talking about again the crystalline solid, when cut with a sharp edged tool, okay, they split into two pieces and the newly generated surfaces are plain and smooth. They are known to be as true solids. Talking about the amorphous solids, when cut with a sharp edge tool, they cut into two pieces with irregular surfaces. The reason for this is clear to you. एक हमारा बिल्कुल ही arranged solid है, fine. Crystalline solid एक non-uniform solid है, जहाँ पर obviously we are going to get the irregular surfaces. Okay, amorphous solids को हम pseudo solids कहते हैं या फिर super cooled liquids भी कहते हैं. या फिर सुपर कूल्ड लिक्विड्स भी कहते हैं. अच्छा, सूडो सॉलिड्स क्या होते हैं? व्हाट यू मीन बाय सूडो सॉलिड्स? सी, सूडो सॉलिड्स आर दोज टाइप्स ऑफ सॉलिड्स व्हिच हैव अपीयरेंस, which do have appearance as a solid. Pseudo solids are those solids which do have appearance as that of a solid, but still they act like liquid. But still they act like what they are. Yes, Akash ने बिल्कुल सही कहा. False solid. Okay, fine. But still they act like liquid. Why? Because they do have a tendency to flow which is very, very quite slow. Okay, and it is slow. It is actually so much slow that you can't observe it with your naked eyes. Okay, so you can also say that these pseudo solids, they do have high viscosity. Okay, so glass is one of the example of pseudo solids. Yes, okay, so they do have high viscosity and they move so much slow that we cannot actually observe it through our naked eyes. That's what, absolutely right. Okay, fine. Moving ahead, and here's the question for you guys. Just let me know. Which one is called the pseudo solid? Which one is called to be as the pseudo solid? Okay, pseudo solid. Is it CaF2, glass, NaCl or all? Just come on dear ones, let me know. Yes Akash, it's option number B, glass is the pseudo solid. Because अभी मैंने आपको बताया भी था, I just told you about the same. Yes dear ones. Okay, चलिए dear one, moving ahead and let's talk about unit cell. Unit cell के बारे में बात करते हैं. Okay, so shall we start unit cell? It's only 20 minutes to go for the class, but yes, we will be starting unit cell and I'll make sure that I make you understand each and every point clearly. यहाँ से questions बहुत आते हैं. Unit cell जो हम पढ़ने जा रहे हैं, okay, we'll be actually talking everything in detail, okay, whatever we learn. But from here, from this particular very point, we are actually going to get questionnaires from JEE, okay. JEE में बहुत सारे questions आते हैं, okay. Yeah, obviously, if I just talk about the weightage, तो weightage में ऐसा मैं कहूँगी कि 1 to 2 questions for sure आते ही आते हैं. Okay, fine. So we're talking about unit cell, and here we go and we'll talk about unit cell. But before I talk anything about unit cell, I want to make few points clear to you. जैसे कि lattice points क्या होते हैं. Unit cell को पढ़ने से पहले, before we talk about unit cell, let's know about what we mean by lattice point. Okay, write it down in your notebooks. What you mean by lattice point? Each constituent particle, whether it is molecule, atom or ion, they will be represented by a dot, okay, and each dot is known to be as lattice point. अभी आप लिख लीजिए जो मैं आपको बता रही हूँ, सारी चीजें क्लियर होंगी, ओके, घबराइएगा नहीं। यहाँ से the very important part of the solid state has been started, so you need to have more focus over here. So each constituent particle, whether it is molecule, atom or ion, they will be represented by a dot, and each dot is known to be as lattice point. ठीक है, अब अगर मैं बात करती हूँ lattice, okay, if I just talk about lattice, or you can say space or crystal lattice, ओके, और क्रिस्टल लैटिस, अगर मैं इनकी बात करती हूँ, व्हाट वी मीन बाय देम, यहाँ पर व्हाट वी आर गोइंग टू से द 3D रेगुलर एंड रिपीटिंग अरेंजमेंट, द 3D रेगुलर and repeating arrangements of what constituent particles represented by the dots in a solid, it is known to be as crystal lattice कह सकते हैं, या space lattice भी आप कह सकते हैं, ठीक है। 3D रेगुलर एंड रिपीटिंग अरेंजमेंट बताऊंगी, 3D के बारे में भी बताऊंगी, ओके। तो वहां पर रेगुलर एंड रिपीटिंग अरेंजमेंट होना चाहिए, किसका, कॉन्स्टिट्यूएंट पार्टिकल्स का, दे आर रिप्रेजेंटेड बाय द डॉट्स, ओके, दे आर रिप्रेजेंटेड बाय द डॉट्स इन अ सॉलिड। क्लियर है, ओके, फाइन, एनी इश्यूज, नो इश्यूज। वन मोर थिंग, अगर कोई पूछे व्हाट यू मीन बाय क्रिस्टल लैटिस इन लेमैन लैंग्वेज, तो आपको क्या बताना है, कलेक्शन ऑफ पॉइंट्स विच आर पीरियोडिक इन स्पेस, ठीक है, कलेक्शन ऑफ पॉइंट्स, कलेक्शन ऑफ पॉइंट्स विच आर पीरियोडिक, विच आर पीरियोडिक in space. Mr. Akash, very soon we'll be doing so have patience, listen to what I want to say over here. सबसे पहले मैंने लैटिस पॉइंट क्लियर किया, ईच कॉन्स्टिट्यूएंट पार्टिकल, चाहे वो एटम हो, मॉलिक्यूल हो, आयन हो, इट इज रिप्रेजेंटेड बाय अ डॉट एंड ईच डॉट इज नोन टू बी एज लैटिस पॉइंट। फिर मैंने आपको बताया स्पेस लैटिस के बारे में, या फिर आप कहिए द क्रिस्टल लैटिस के बारे में। तो एक तरह से क्रिस्टल लैटिस या स्पेस लैटिस को आप क्या कहेंगे, द कलेक्शन ऑफ पॉइंट्स विच आर पीरियोडिक इन स्पेस, इट इज नोन टू बी एज क्रिस्टल लैटिस, इट इज नोन टू बी एज क्रिस्टल लैटिस, ठीक है। या फिर 3D थ्री डायमेंशनल स्पेस के अंदर रेगुलर एंड रिपीटिंग अरेंजमेंट ऑफ कॉन्स्टिट्यूएंट पार्टिकल्स, दे आर रिप्रेजेंटेड बाय अ डॉट। ये सब चीजें क्लियर करूंगी, उसकी चिंता आप मत कीजिएगा, ठीक है। क्रिस्टल लैटिस इज बेसिकली एन इमेजिनरी थिंग, इस बात का भी ध्यान रखिएगा, ठीक है। अगर मैं 3D, अगर मैं सपोज करो पहले 1D लैटिस के बारे में बात करती हूँ, इफ आई जस्ट टॉक अबाउट 1D लैटिस, ठीक है, तो देखिए ये एक पॉइंट है, देन दिस इज, आप इसे कुछ भी मान सकते हैं, एटम, मॉलिक्यूलर, आयन। सो दिस पर्टिकुलर लैटिस पॉइंट, देन अगेन अ 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 लैटिस पॉइंट। ये वन डायमेंशनल लैटिस की मैं बात कर रही हूँ, जहां पर व्हाट आई एम सीइंग repeating of these particular lattice point in one dimensional space. If I just talk about 2D lattice के बारे में अगर मैं बात करती हूँ, if I just talk about the 2D lattice, तो देखिए it's 1 2 3 4 5, यहाँ देखिए आप, okay, fine, are you seeing the things, there is repeating of the point, regular repeating, okay, what you are seeing, it's the regular and repeating arrangement of constituent particles represented by the dots in a solid. क्लियर है ये वाली चीज, ठीक है। 2 डायमेंशनल के से हम बात कर रहे हैं, जैसे पेपर पे हम ड्रॉ करते हैं, दैट इज 2 डायमेंशनल बेसिकली, ओके। आर यू गेटिंग द थिंग्स क्लियर आउट ऑफ हियर, ओके, फाइन, ओके। सो व्हाट यू आर सीइंग, अगर आप इसको लेते हैं, इफ यू जस्ट चेक दिस, see this, then repeating here, then repeating here, then repeating here and now here. So this is what I want to clear about the things, ठीक है। तो यहाँ पर 2D lattice में we do have 2 axes, suppose it's x axis and y axis. So x and y direction के along, x and y direction के along repeat होना, x and y direction के along repeat होना, ठीक है। ऐसे ही अगर मैं बात करती हूँ 3D लैटिस के बारे में, सो x, y एंड z डायरेक्शन के अलोंग रिपीट होना, रेगुलरली रिपीट होना, एक पर्टिकुलर अरेंजमेंट बनना। क्लियर है ये वाली चीज, प्रिय, आकाश, मयूर। अभी हम ए टाइप के बारे में नहीं बात करें, अभी सिर्फ मैं बता रही हूँ कि 1 डायमेंशनल लैटिस एंड 2 डायमेंशनल लैटिस एंड 3 डायमेंशनल लैटिस, ठीक है। अब हम बात करते हैं यूनिट सेल के बारे में, ठीक है। बट उससे पहले एक और चीज बताना चाहती हूँ, सिंस मैंने आपको क्रिस्टल के बारे में बताया। यस, कलेक्शन ऑफ लैटिस पॉइंट इज कॉल्ड व्हाट? कलेक्शन ऑफ पॉइंट्स या लैटिस पॉइंट्स विच आर पीरियोडिक इन स्पेस इज नोन टू बी एज क्रिस्टल लैटिस, ठीक है। क्रिस्टल स्ट्रक्चर जो होता है, इट इज द कलेक्शन ऑफ स्ट्रक्चरल मोटिव्स अरेंज्ड अकॉर्डिंग टू द लैटिस। स्ट्रक्चरल मोटिव्स का मतलब क्या है? यहाँ पर 2D या 3D के बारे में आप बात कर रहे हैं। सो अब अगर मैं बात करती हूँ यूनिट सेल के बारे में, व्हाट यू मीन बाय यूनिट सेल? एक क्रिस्टल का छोटा सा पोर्शन होता है, ओके एक क्रिस्टल का छोटा सा पोर्शन, ओके। सो अ पोर्शन ऑफ क्रिस्टल which if repeated, a portion of crystal which, yes, absolutely right Rishabh, a portion, a very small portion of the crystal which if repeated along certain axes after certain distances, it can regenerate the entire crystal, and that is called unit cell. दोबारा से सुनिए और लिखिए इसको। A portion of crystal, okay, which if repeated along certain axes after certain distance, it can regenerate the entire crystal, and that is called unit cell, and that is called unit cell. Okay, fine. Is the thing clear to you? कोई doubt? I don't believe so. There won't be any doubt to you guys. Okay, fine. तो चलिए, सो यूनिट सेल इज द स्मॉलेस्ट पोर्शन ऑफ द लैटिस। सपोज कीजिए हमारा ये है, ये सपोज करते हैं हम, दिस इज आर, ये हमारा पूरा क्रिस्टल है, ठीक है। एंड सपोज कीजिए ये हमारा लैटिस पॉइंट है। अभी ये देखिए रिपीट हो रहा है, फिर ये रिपीट हो रहा है along a certain axis at a certain distance, isn't it? Yes. So unit cell is usually the smallest portion of a lattice which when repeated in different direction generates the entire lattice. अगर ये x axis के along repeat हो रहा है, so after a certain distance, suppose कीजिए वो a है, so along x axis, okay, after what we can say, along x axis after a certain distance which is a, we are actually getting our lattice point. अगर मैं y axis के अकॉर्डिंग बताऊं, सपोज कीजिए ये b डिस्टेंस है, सो along y axis it is repeating, okay, at a b distance. क्लियर हो रही है ये वाली बात क्लियर हो रही है? एनी डाउट ओवर है? फाइन, चलिए मूविंग अहेड। सो ओवर है I told you about the lattice, x to x same. हाँ, मतलब ऋषभ I want to say कि ऐसे हम x axis की बात कर रहे हैं। So x axis में what we are seeing, a portion of a crystal की अगर मैं बात करूँ, it is repeating along x axis after certain distance, वो distance हमने a ले लिया, ठीक है। So it can actually regenerate the entire crystal. अब अगर मैं y axis की बात करती हूँ, since मैं 2 dimensional की बात कर रही हूँ, so along y-axis, okay, what is actually happening? Along y-axis, after a certain distance b, we can generate the entire crystal, and that is called the unit cell. ठीक है, ये बात क्लियर हो गई। certain distance मैंने आपको बताया, ठीक है। तो लैटिस के बारे में भी यहाँ पर चीजें क्लियर हो गई हैं। ओके, सो लैटिस और स्पेस लैटिस और स्पेस और क्रिस्टल लैटिस के बारे में मैंने आपको बता दिया था। द 3D रेगुलर एंड रिपीटिंग अरेंजमेंट ऑफ कॉन्स्टिट्यूएंट पार्टिकल्स रिप्रेजेंटेड बाय डॉट्स इन अ सॉलिड, जैसे कि आप यहाँ देख रहे हैं, दिस इज अ यूनिट सेल। This is a unit cell. Unit cell क्या है? It is a portion of crystal which if repeated along certain axes after a certain distance, it can regenerate the entire crystal, and that is known to be as unit cell. आप देख रहे हैं यहाँ पर ये क्या है? This is a crystal lattice we have formed. How come? From a unit cell. अब आप देखिए unit cell को अगर हम repeat करें along the certain axis after a certain distance, तो आप यहाँ क्या देख रहे हैं? It's the whole entire crystal lattice that is generating. Clear? Done. Okay, cool. समझ में आ गई ये वाली चीज समझ में आ चुकी है? ओके फाइन। तो अगर ये वाली चीज आपको समझ में आ गई है तो आप आगे क्या किया जाए, व्हाट शुड विल डू? यस, मूविंग अहेड एंड अब हम बात करते हैं एक क्वेश्चन की. सो हियर इज द क्वेश्चन इन फ्रंट ऑफ यू. द स्मॉलेस्ट रिपीटिंग पैटर्न विच व्हेन रिपीटेड इन 3-dimensional results in the crystals of the substance is called space lattice, crystal lattice, unit cell or coordination number. Option number C is the right answer. हाँ जी, ऑप्शन नंबर सी बिल्कुल सही जवाब है. ऑप्शन नंबर सी बिल्कुल सही जवाब है. इट्स द यूनिट सेल. अच्छा, एक और क्वेश्चन. विच ऑफ द फॉलोइंग कैन बी कंसिडर्ड एज द यूनिट सेल ऑफ द गिवन लैटिस? Which of the following can be considered as the unit cell of the given lattice? हम इनमें से A, B, C, D, E and F में से किसको कंसिडर करें यूनिट सेल ऑफ द गिवन लैटिस? देखो, अगर मैं A की बात करती हूँ, अगर दिस इज माई लैटिस, ओके, और अगर मैं इसको रिपीट करूं अलोंग अ सर्टेन डिस्टेंस आफ्टर अलोंग अ सर्टेन एक्सिस, इफ आई जस्ट रिपीट दिस A, ये जो A मेरा यूनिट सेल है, इसको अगर मैं रिपीट करती हूँ अलोंग अ सर्टेन एक्सिस एट अ सर्टेन डिस्टेंस, तो देखिए व्हाट आई एम गोइंग टू गेट. A मिला, फिर दोबारा से यहाँ हमें A मिलेगा, फिर A मिलेगा, फिर A मिलेगा, यहाँ नीचे भी आप देखिए A मिलेगा. मैंने रिपीट किया है, बस मैं सिर्फ रिपीट कर रही हूँ. समझ में आ रहा है आपको? यस मैम. तो ये जो A है इट कैन बी अ यूनिट सेल, बिकॉज जब हम इसको रिपीट कर रहे हैं अलोंग अ सर्टेन एक्सिस आफ्टर अ सर्टेन डिस्टेंस, सो हमें एक पर्टिकुलर एंटायर क्रिस्टल मिल रहा है. सो ये A तो यूनिट सेल है. B की बात करें तो अब ये जो B है दिस इज दिस, ओके, तो अगर मैं इसको रिपीट कर रही हूँ अलोंग अ एक्सिस एट अ सर्टेन डिस्टेंस, तो क्या मुझे यहाँ पर एंटायर क्रिस्टल मिल रहा है? नो, आई एम नॉट गेटिंग. यहाँ देखिए ये स्पेस छूट रहा है यहाँ पर. These are the voids being created over here. So it cannot be the unit cell. ये नहीं हो सकता, B नहीं हो सकता. अगर हम ऑप्शन नंबर C की बात करें, yes it can be. ऑप्शन नंबर C हो सकता है. D की बात करें, ये क्या है हमारे पास में एक हेक्सागन है, तो अगर हम इसको रिपीट करते हैं along a certain axis at a certain distance, तो हमें एंटायर क्रिस्टल मिल जाएगा. ओके, सो D कैन बी देयर. अगर E की बात करें, अगर हम E की बात करते हैं तो ठीक है भाई, अगर मैं E को रिपीट कर रही हूँ तो एक्चुअली आई एम गेटिंग इट. ये देखिए मुझे मिल रहा है. यस आई एम गेटिंग इट. ओके, इसको देखिए यहाँ से रिपीट किया. यस आई एम गेटिंग द एंटायर क्रिस्टल. सो E कैन ऑल्सो बी द यूनिट सेल. टॉकिंग अबाउट F, यार ये थोड़ा सा वियर्ड सा स्ट्रक्चर नहीं लग रहा आपको? ये थोड़ा सा वियर्ड सा स्ट्रक्चर नहीं लग रहा? तो इट कैन नॉट बी द यूनिट सेल. सो इट्स A, C, D and E द राइट आंसर. A, C, D and E कैन बी द राइट आंसर. यस, सी को तो मैंने बोला ही है, ऑप्शन नंबर सी का तो बोला ही है मैंने, इट कैन बी अ यूनिट सेल. सो ए, सी, डी एंड ई आर द राइट आंसर्स. ओके, यस, एब्सोल्युटली राइट. मूविंग अहेड एंड लेट्स टॉक अबाउट द यूनिट सेल इन 2D. यूनिट सेल इन 2 डायमेंशंस की बात करते हैं अब हम. यूनिट सेल इन 2 डायमेंशंस की हम बात करते हैं, ठीक है. तो देयर आर 5 टाइप्स ऑफ यूनिट सेल्स पॉसिबल इन 2D लैटिस. 2D लैटिस में हमें 5 तरह के यूनिट सेल्स मिलेंगे. 2D लैटिस में हमें 5 टाइप्स ऑफ यूनिट सेल मिलने वाले हैं. 5 टाइप्स ऑफ यूनिट सेल हमें मिलेंगे. नाउ यूनिट सेल इन 2D इज पैरेललोग्राम व्हिच इज डिस्क्राइब्ड बाय 3 पैरामीटर्स A, B एंड गामा. ठीक है, अब ये मैम A, B एंड गामा क्या है? A, B एंड गामा, दीज आर द सेल पैरामीटर्स. दीज आर द सेल पैरामीटर्स डियर वन. ठीक है, अभी हमने क्या बात की? देयर आर 5 टाइप्स ऑफ द यूनिट सेल पॉसिबल इन 2D लैटिस. इस बात का याद रखिएगा. यूनिट सेल इन 2D इज पैरेललोग्राम which is described by 3 parameters A, B and gamma. A, B and gamma, these are the cell parameters. ठीक है, सेल पैरामीटर्स क्या होते हैं मैम? देखिए, अगर मैं 1 डायमेंशनल की बात करती हूं जहां पर यहाँ पर डायरेक्शन का कोई पंगा नहीं है, देयर इज नो इश्यूज ऑफ द डायरेक्शन, एक डायमेंशनल एक पर्टिकुलर प्लेन के अंदर है. यस, ठीक है. सो यहाँ पर स्ट्रेट लाइन है, यहाँ स्ट्रेट लाइन है. आफ्टर अ सर्टेन डिस्टेंस पॉइंट्स आर रिपीटिंग. आफ्टर अ सर्टेन डिस्टेंस द पॉइंट इज रिपीटिंग. वो डिस्टेंस सपोज कीजिए यहाँ पर ये A है, ठीक है, तो मैं यहाँ पर कहूंगी इट्स only one cell parameter we do have for 1 dimensional. ठीक है, लेकिन अगर मैं बात करती हूँ 2 डायमेंशन की, इफ आई जस्ट टॉक अबाउट टू डायमेंशनल, जैसे यहाँ दिया हुआ है इन टू डायमेंशनल, दोनों डायमेंशंस में इन टू डायमेंशनल दो डायमेंशंस होंगी यहाँ पर, एक्स एक्सिस के अलोंग एंड वाई एक्सिस के अलोंग, है कि नहीं? यस ऑफ कोर्स। सो दोनों डायमेंशंस में पॉइंट्स जो हैं वो रिपीट कर रहे हैं। ओके, सो वी कैन से वन थिंग, जैसे कि अगर मैं यहाँ की बात करती हूँ, यहाँ गई देन इधर गई, तो एक्स एक्सिस के अलोंग द पॉइंट्स आर रिपीटिंग एंड लेट द डिस्टेंस बी ए, ठीक है, यहाँ ए हो गया, एंड वाई एक्सिस के अलोंग मैं यहाँ से यहाँ गई एंड लेट द डिस्टेंस बी बी, ठीक है, क्लियर है? सो एक्स एक्सिस के अलोंग, इस पर्टिकुलर लाइन के अलोंग पॉइंट्स जो हैं ए के बाद में रिपीट हो रहे हैं। If I talk about x axis, these particular lattice points, they are repeating, okay, after a distance a, after a distance a. Similarly, अगर मैं y axis की बात करती हूँ, तो इस लाइन के particularly what, इस लाइन के along the points are repeating after a certain distance b. तो दोनों डायमेंशंस में we are actually seeing that the points are repeating, ठीक है? So a and b are the cell parameters, and if I just talk about the angle gamma, fine. So it's the angle gamma between a and b basically. It's the angle gamma, angle between a and b. Okay, so a and b are what? It's the cell parameter, and there is also one cell parameter, the angle between a and b gamma. So cell parameters की वजह से ही हम पूरा लैटिस रीजनरेट कर सकते हैं, सेल पैरामीटर्स की वजह से ही, बिकॉज ऑफ सेल पैरामीटर्स ओनली वी कैन रीजनरेट द होल लैटिस, वी कैन रीजनरेट द होल लैटिस। प्रिया, समझ में आया? प्रिया, आकाश, ऋषभ, द थिंग्स हैव बीन क्लियर टू यू गाइज? इफ any doubt, just let me know. Yes, our cell parameters can form different shapes of the unit cell. आपने सही बोला, and these cell parameters, they are responsible for what? Regeneration of the whole lattice, ठीक है? Now, since I told you that we do have 5 unit cell when we talk about 2D, okay, when we are talking about 2D, so very first unit cell, it's the square, wherein a equals to b and gamma equals to 90 degree. This is what you need to learn. This is what you need to learn. Question straight away कभी कभार पूछ लिया जाता है, ठीक है? So square, rectangle, hexagonal. In rectangle, a not equals to b. In hexagonal, a equals to b. Talking about the angle, so a not equals to b, but gamma equals to 90 degree. In hexagonal, if I just talk about, gamma equals to 120 degree. Okay. Talking about the other two, rhombic and parallelogram, in rhombic a equals to b and gamma you can just see not equal to 90 degree, not equal to 60 degree, not equal to 120 degree. सबसे गंदा यूनिट सेल है ये, rhombic वाला सबसे गंदा यूनिट सेल है कि नहीं? जहां पर एंगल बिटवीन a and b is neither 90, neither 60, neither 120. Talking about parallelogram, wherein a not equal to b and gamma also not equal to 90 degree. तो ये जो 5 यूनिट सेल हैं 2D में, प्लीज लर्न देम। इनमें से सबसे ज्यादा जो सिमेट्रिकल है, इट इज द स्क्वायर यूनिट सेल। स्क्वायर यूनिट सेल सबसे ज्यादा सिमेट्रिकल है। डू रिमेंबर दिस पर्टिकुलर पॉइंट। डन। सो यू नीड टू लर्न कि 2 डायमेंशनल में वी डू हैव 5 यूनिट सेल, ओके, स्क्वायर, रेक्टेंगल, हेक्सागोनल, रोम्बिक जो सबसे 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 ज्यादा गंदा है, एंड इट्स द पैरेललोग्राम। ओके, क्लियर है? ओके, कूल गाइज। मूविंग अहेड, और हम बात करते हैं यूनिट सेल इन 3 डायमेंशनल। यूनिट सेल इन 3 डायमेंशनल। तो इन 3 dimensional lattice to specify any unit, 6 parameters are required. तो 3 dimensional unit cell के अंदर we actually require 6 parameters, क्योंकि यहाँ पर देखिए we'll be talking about 3 directions, x axis, y axis and z axis. Okay, तो उनके along अगर देखा जाए तो we'll be having 3 edge lengths a, b and c and 3 angles between them, which is alpha, beta and gamma. Okay, so in 3D unit cell अगर हम बात करते हैं, there are 6 cell parameters, a, b and c the edge length, alpha, beta, gamma the angles between them. Okay, here you can have a look for 3D unit cell. Okay, so ये हमारा a edge length, this one is the b edge length, this one is the c edge length, and the angle between them are alpha, beta and gamma. Hope the thing is clear to you. समझ में आ गई ये वाली बात? ये बताइए, ये यहाँ तक क्लियर हुआ? तो आगे हम बढ़ते हैं। ब्रेविस लैटिस। देखिए ब्रेविस जो था, ब्रेविस जो थे, ओके, ही वॉज अ ग्रेट साइंटिस्ट। उन्होंने बहुत सारे मैथमेटिकल एक्सपेरिमेंट्स किए एंड बहुत सारे परम्यूटेशन एंड कॉम्बिनेशंस लगाए, एंड एट द एंड what he actually resulted in कि there are 14 different types of the unit cell. Brevis, who was a scientist, he actually did huge mathematical calculations, gave us the proofs, did very much permutation and combination things, and at the end जो result हमें मिला, it was कि there are in total 14 different types of the unit cell, and hence they are known to be as Brevis lattice. In 3D lattice, 14 different types of the unit cell are found, and these are also known to be as Brevis lattice. Okay. Now, these 14 unit cells are grouped in 7 crystal system. 7 crystal systems के अंदर we do have these 14 unit cells. Okay. Depending upon the 7 types of primitive unit cell. अब आप ये पूछेंगे कि मैम ये प्रिमिटिव यूनिट सेल क्या है? प्रिमिटिव यूनिट सेल्स आर दोज यूनिट सेल्स, सपोज अगर मैं 3D यहाँ पर क्यूब बना रही हूँ, सो प्रिमिटिव यूनिट सेल्स आर दोज यूनिट सेल्स विच डू हैव द लैटिस पॉइंट्स ओनली एट द कॉर्नर्स, which do have the lattice points only at the corners. क्यूब में 8 कॉर्नर्स हैं, तो 8 कॉर्नर्स पे we do have the lattice point. ठीक है, अब ये लैटिस पॉइंट जैसे सपोज कीजिए हम बात कर रहे हैं NaCl की, तो यहाँ एक NaCl, फिर दूसरा NaCl, देन थर्ड NaCl, फोर्थ NaCl, फिफ्थ, सिक्स्थ, सेवेंथ, एट्थ, काइंड ऑफ लाइक दिस. आप ये नहीं कहेंगे कि NaCl मीन्स Na पॉजिटिव एंड Cl नेगेटिव है, तो एक लैटिस पॉइंट पे Na पॉजिटिव आ जाएगा, दूसरे पे Cl नेगेटिव. नहीं, इट विल बी NaCl ऑन वन लैटिस पॉइंट and it will be another NaCl on another lattice point. Okay, fine. या भी डू, देखिए सुनिए, अभी मैं बात करूंगी आकाश, उनकी भी बात करूंगी. ये जो आप एज सेंटर एंड फेस सेंटर यूनिट सेल की बात करें, दीज आर नॉन प्रिमिटिव यूनिट सेल. प्रिमिटिव यूनिट सेल वो यूनिट सेल होते हैं जहां पर वी डू हैव लैटिस पॉइंट्स ओनली एट द कॉर्नर्स, एंड नॉन प्रिमिटिव यूनिट सेल्स वो होते हैं जहां पर वी डू हैव लैटिस पॉइंट ऑन द कॉर्नर्स एज वेल एज ऑन द फेस सेंटर्स, on the body center, on the edge center. ठीक है, क्लियर है? तो जो हमारे 14 यूनिट सेल जो ब्रेविस ने हमें बताए, दे आर एक्चुअली ग्रुप्ड इन 7 क्रिस्टल सिस्टम डिपेंडिंग अपॉन 7 टाइप्स ऑफ प्रिमिटिव यूनिट सेल. आगे देखिए, समझ में सब कुछ आएगा. क्रिस्टल सिस्टम्स की हम बात करते हैं, ये बहुत ज्यादा इंपॉर्टेंट है, इनको आपको याद करना होगा. एक ट्रिक है, वो मैं आपको बताऊंगी, आपको चीजें फिर क्लियर हो जाएंगी. यू नीड टू एक्चुअली लर्न देम. ठीक है, सबसे पहले क्यूबिक के बारे में बात करते हैं. वहां पर जो एज लेंथ है, इट इज A इक्वल्स टू B इक्वल्स टू C, एंड एंगल्स क्या है, अल्फा इक्वल्स टू बीटा इक्वल्स टू गामा 90 डिग्री. यूनिट सेल कौन से इस क्रिस्टल सिस्टम में पाए जाते हैं? दे आर प्रिमिटिव BCC एंड FCC. BCC means body centered cubic unit cell, body centered cubic unit cell. FCC means face centered cubic unit cell. आकाश ने बिल्कुल सही बोला, क्यूट आर मदर. एक और है, it's store HMT, HMT का store, so it's CTOR HMT, store HMT. ओके, ये भी हो सकता है. टेट्रागोनल की बात करते हैं, A इक्वल्स टू B नॉट इक्वल टू C, बट द एंगल्स अल्फा इक्वल्स टू बीटा इक्वल्स टू गामा 90 डिग्री. एंड कौन से यूनिट सेल पाए जाते हैं इसमें? प्रिमिटिव एंड बॉडी सेंटर्ड यूनिट सेल. टॉकिंग अबाउट ऑर्थोरोम्बिक क्रिस्टल सिस्टम, यहाँ पर एज लेंथ जो है कोई भी सेम नहीं होती. A not equal to B not equal to C, but the angles are alpha equals to beta equals to gamma 90 degree. कौन से यूनिट सेल इसमें पाए जाते हैं? BCC, प्रिमिटिव यूनिट सेल, BCC यूनिट सेल, फेस सेंटर यूनिट सेल एंड एज सेंटर यूनिट सेल. ये 3 हमने पढ़ लिए, जहां पर एंगल्स जो थे दे आर कॉरस्पॉन्डिंग इक्वल्स टू 90 डिग्री, बट A इक्वल्स टू B इक्वल्स टू C फॉर क्यूबिक, A इक्वल्स टू B नॉट इक्वल टू C फॉर टेट्रागोनल, A नॉट इक्वल टू B नॉट इक्वल टू C फॉर ऑर्थोरोम्बिक. एग्जाम्पल्स भी याद कर लीजिएगा. ठीक है, अब हम बात करते हैं रोम्बोहेड्रल या फिर कहिए ट्रायगोनल की. यहाँ पर A इक्वल्स टू B इक्वल टू C है. एंगल जो है अल्फा इक्वल्स टू बीटा इक्वल्स टू गामा तो है, बट इट्स दे आर नॉट इक्वल टू 90 डिग्री. कौन सा यूनिट सेल मिलता है? ओनली प्रिमिटिव. हेक्सागोनल में A इक्वल्स टू B नॉट इक्वल टू C, एंड एंगल की अगर हम बात करें, अल्फा इक्वल्स टू बीटा इक्वल्स टू 90 डिग्री एंड गामा इक्वल्स टू 120 डिग्री, यूनिट सेल ओनली प्रिमिटिव यूनिट सेल यहाँ पाया जाता है. टॉकिंग अबाउट मोनोक्लिनिक एंड ट्राइक्लिनिक नाउ, सो ए नॉट इक्वल टू बी नॉट इक्वल टू सी. ऐसे ही ट्राइक्लिनिक में सबसे गंदा है ट्राइक्लिनिक, इसमें कुछ भी सेम नहीं होता है. ए नॉट इक्वल टू बी नॉट इक्वल टू सी, अल्फा नॉट इक्वल टू बीटा नॉट इक्वल टू गामा नॉट इक्वल टू 90 डिग्री. तो इसमें प्रिमिटिव यूनिट सेल हम इसकी बात करेंगे. मोनोक्लिनिक में इट्स अल्फा इक्वल्स टू गामा 90 डिग्री, बीटा नॉट इक्वल टू 90 डिग्री, नॉट इक्वल टू 120, नॉट इक्वल टू 60. एंड येस इट्स द प्रिमिटिव एंड एन सेंटर्ड यूनिट सेल जो इसमें पाया जाता है. ये आपको याद करना जरूरी है, क्वेश्चन कभी कभी स्ट्रेट अवे पूछा जाता है. वेल नोट क्या है जो मैंने आपको बताया था, एंड जो आकाश ने बोला क्यूट आर मदर, वो भी सही है. और स्टोर एचएमटी से आप देख लीजिए, इट्स क्यूबिक, ओके, इट्स टेट्रागोनल, it's orthorhombic, it's rhombohedral, it's hexagonal, it's monoclinic and it's triclinic. समझ में आ गया? क्लियर है? बहुत इजी है, याद कर लीजिएगा, बहुत काम की चीज है. अब हम बात करते हैं टाइप्स ऑफ यूनिट सेल के बारे में, जो कि अभी अभी हमने बात की थी प्रिमिटिव यूनिट सेल एंड नॉन प्रिमिटिव और सेंटर यूनिट सेल के बारे में. व्हाट वी मीन बाय प्रिमिटिव यूनिट सेल, मैंने आपको बताया था यूनिट सेल दैट हैव लैटिस पॉइंट्स ओनली एट द कॉर्नर्स. ठीक है, तो आप यहाँ देखिए, दिस इज द यूनिट सेल. हाउ टू मेमोराइज द पैरामीटर्स, बहुत इजी है. एक बार आपको बताऊं आकाश, ये तो आपने याद कर लिया क्रिस्टल सिस्टम, उसके कॉरेस्पॉन्डिंग आप ना एक पर्टिकुलर ट्रेंड देखेंगे. ए इक्वल्स टू बी इक्वल्स टू सी, ए इक्वल्स टू बी नॉट इक्वल टू सी, ए नॉट इक्वल टू बी नॉट इक्वल टू सी. ये देखना, ये ट्रेंड आप देखेंगे ना तो आपको इजीली याद हो जाएंगे. घबराइएगा मत, बहुत ईजी है याद करने के लिए. जब आप क्यूट आर मदर ये पर्टिकुलर हमने मेमोराइज किया है इसके अकॉर्डिंग, तो अब जो पैरामीटर्स हैं दे आर नाउ वेरी इजी टू लर्न. ठीक है, आप ट्रेंड देखेंगे, वो ट्रेंड रिपीट होगा एंड यू विल बी लर्निंग देम वेरी सून. ठीक है, प्रिमिटिव यूनिट सेल मैंने आपको बताया. सो इट्स द सिंपल यूनिट सेल, जहां पर आप देख रहे हैं we are actually having the lattice points only at the corners. Molecules, atoms और ions या जो भी हम बात कर रहे हैं, ionic salts की जो हम बात कर रहे हैं, they are only at the corners of the unit cell. ठीक है, क्लियर है. अगर मैं बात करती हूँ नॉन प्रिमिटिव और सेंटर यूनिट सेल की, तो मैंने जैसा कि आपको बताया था, यूनिट सेल हैविंग द लैटिस पॉइंट एट द कॉर्नर्स एज वेल एज विद इन द यूनिट सेल. अब इसमें वील बी टॉकिंग अबाउट द 3 यूनिट सेल: बॉडी सेंटर्ड यूनिट सेल, फेस सेंटर्ड यूनिट सेल एंड एंड सेंटर्ड यूनिट सेल. बॉडी सेंटर्ड यूनिट सेल का मतलब ये है that we are going to have the lattice points at the corners as well as in the body center. बॉडी क्यूब का जो सेंटर है उसके बीच में भी लैटिस पॉइंट होगा. तो बॉडी सेंटर्ड यूनिट सेल में वी आर गोइंग टू हैव द लैटिस पॉइंट नंबर 1 एट द कॉर्नर्स, नंबर 2 इन द बॉडी सेंटर. टॉकिंग अबाउट फेस सेंटर, फेसेस, क्यूब के कितने फेसेस होते हैं? There are 6 faces and we are talking about face center. तो उन 6 faces के center पे भी we are going to have the lattice point along with, yes absolutely Akash, along with the lattice point at the corners. So corners में तो lattice point होंगे तो हैं. We are going to have lattice points at corners plus face centers. Plus face center, okay? So we do have 6 faces, 6 face centers. So here you can see one up, the other one below, second this and this, okay? You are getting the things. एक ऊपर, एक नीचे, एक right, एक left, okay? एक आगे और एक पीछे. समझ में आया ये वाली बात? मिस्टर हेमाचंद्रन, let me tell you, non-primitive unit cell ऐसे unit cell होते हैं जहां पर lattice points सिर्फ कॉर्नर्स पे ही प्रेजेंट नहीं है, दे आर ऑल्सो प्रेजेंट इनसाइड द यूनिट सेल. जैसे कि मैंने बात की बॉडी सेंटर की, तो कॉर्नर्स पे तो यूनिट सेल थे, दैट इज ओके, बट अलोंग विद द कॉर्नर बॉडी के सेंटर में भी एक यूनिट सेल प्रेजेंट था. फेस सेंटर में जैसे कि हम बात कर रहे हैं कॉर्नर्स पे, एट द कॉर्नर्स वी आर एक्चुअली हैविंग द लैटिस पॉइंट, बट अलोंग विद द कॉर्नर्स वी आर एक्चुअली हैविंग द लैटिस पॉइंट ऑन द फेस सेंटर. हियर यू कैन जस्ट सी. Okay, talking about the last one, it's the end center unit cell, wherein what we are going to have, we are going to have the lattice point at the 8 corners. Cube has 8 corners, so we are going to have lattice points at the 8 corners and plus opposite phases. Okay, these are the end center. Up, below, ऊपर, नीचे. Okay, you can have the lattice point here also, or else you can have the lattice point here also, or else you can have the lattice point over here also, on the opposite phases. Okay, we are end center means we are actually having the lattice point on the opposite phases. So this is up phase, this is down phase, or else you can have the lattice point sidewise, okay, opposite phases, or else you can have the lattice point over here also in end center. The question is in front of you, okay. So if you are talking about end center, so yes, how can we can have the 10 lattice point in end center? End center, oh yes, it's yes, absolutely right. I thought you are talking about face center. Sorry, I didn't read it properly. Yes, absolutely right, Akash. So the question is in front of you, in the face center unit cell. If we are talking about face centered unit cell, the lattice points are present where? The lattice points are present at the corners of the unit cell, absolutely right. Corners and the center of the unit cell, no, it actually tends for BCC, body center unit cell. Corners and the edge center of the unit cell, no, it is for end center, it is for edge center unit cell. We are not talking about this, okay. So B and C out. D says face center of the unit cell, absolutely right. Yahi to humne padha tha. This is what we talked about. So it's A and D the right answer. The next question in front of you. Choose the correct statement or statements. There are 5 types of unit cell possible in 2D lattice. There are 5 types of unit cell possible in 2D lattice. Yes, there are 5 unit cell possible in 2D lattice. The one is square, the other one is hexagonal, okay, then rhombic, okay, 2 more. What else we do have in 2D? Can you just let me know? Parallelogram, okay ma'am. Okay, so yes, it's option number A, the right one. There are 5 unit cells possible in 2D lattice. Okay, yes, it's absolutely right. The most symmetrical unit cell in 2D lattice is cube. No, it is the square unit cell. It is the square unit cell. Yes, square, rectangle, hexagonal, parallelogram, rhombus. बिल्कुल सही बोला आकाश आपने. Okay, yes. So it's the square unit cell that is most symmetrical. Cube तो है ही नहीं भाई. है कि नहीं? So B is out of the race. Talking about option number C, in 3D lattice, to specify any unit cell, yes, absolutely right Akash, वही मैंने बोला, cube तो होगा ही नहीं, okay? So in 3D lattice, to specify any unit cell, 6 parameters are required. Yes, 6 parameters are required. Talking about option number D, in 3D lattice, 12 different types of unit cell are found. No, there are 14 different types of unit cell that are found. And your homework for tomorrow's class is that you are going to learn those 7 crystal system along with the cell parameters relationship between the edge length as well as between the angles. Okay, so your homework for tomorrow is that you need to learn all the 7 crystal system along with their parameters, their angles, and with the examples. When I'll actually come to the class, first of all I'll be talking about the same, I'll be asking you the questions for the same. So be ready for it, okay? Go with the hint, go with the memorizing trick, and we'll be talking about the same in tomorrow's class, the very first thing I'm going to do tomorrow. So dear one, this was the end to the session. So आज हमने क्या पढ़ा? We talked about the solids in the unit cell. We talked more in detail about amorphous and crystalline solids. Then we talked about unit cell, lattice point, crystal lattice, 1-dimensional, 2-dimensional, 3-dimensional, cell parameters, all of the basic things which we require in the upcoming session, dear ones. So the upcoming session for today's day, it will be of Target JEE 2023 Physics, sharp at 4 p.m. So do not miss that particular session, dear one. Okay, and thank you so much. Thank you so much. No, Akash. It will be today itself. By mistake, the date might have been written. So sorry for that particular thing. Yes, I know, Mayur, the date is wrong. I'm really sorry for that. But in today's, for the today's day, it will be at 4 p.m. the physics class that is going to come up. So thank you so much, guys, for your cooperation, for being there and listening to me. We'll be meeting soon tomorrow sharply again at 12 p.m. with the next session of solid state. Till then, do revise the chapter, whatever we have talked for, and we'll be talking about the same tomorrow now. Bye-bye.